Hi everyone, welcome back to our new video of the series where we are going to discuss about space complexity. So in this video, we are going to discuss the concept of space complexity. If you remember in our previous video, we have discussed what are the basics of algorithms, what are the properties of algorithm and how we measure efficiency of an algorithm. In that we discussed that efficiency of algorithm can be can be calculated by two ways, that is time complexity and the space complexity. So in today's video we are going to discuss about space complexity and we are going to understand the fundamental principle of how to calculate the space complexity, right? So before going to calculate that, let's understand what is space complexity. So as we know that space complexity is nothing but the space, or you can say a memory required required for an algorithm, or you can write as program to execute, right? So we have seen this already, but I'm just reiterating that what is space complexity? It is nothing but a extra space or a space required for an algorithm to execute, right? So how we calculate a space complexity? So the general formula of space complexity is given by S of P is equals to C plus SP. It looks very easy, but sometimes it creates a chaos because we don't understand what each term mean here, right? So we need to understand a very basic of this formula and then we are going to apply it and solve multiple problems, right? So the formula is very basic, you can understand it. It has three stuff: S of P, C and SP. What this S of P means? It means that space of a algorithm or a space of a problem. Let me write as space of a problem because I'm denoting bit P, so it will be a bit familiar to you. That P means space of a problem. What C means? C means a constant part, which is, you can say, anything which is independent, or you can write it as it's a local variable, right? So any local variable which is not dependent means it's fixed, right? For example, if you are defining int a, right? Now you know that a is of what data type? Integer, and cannot go beyond 4 bytes, right? So it's already fixed, and this a is now independent. If you're doing typecast, then again you going to, doing the conversion, then again you are going to fix it. But let's not go into that detail. But what I'm saying is here C represents the constant part which is independent, or you can say a local variable, right? To understand as of now, right? Now what this S of P means, this is very important. This is a variable part, and this is basically which is dependent, right? Which is dependent, right? How many times a loop will execute, right? So that has a dependency, right? The number of times you are going to iterate the loop, that is what S of P, right? So it basically talks about the auxiliary variable, right? It's talk about the auxiliary variable. Understand? What is sometimes people say this as an auxiliary space. Auxiliary space, right? What that means? That means it is nothing but extra space required by algorithm, right? So I think now you understand the formula. The formula is very simple, that it is S of P is equals to C plus S of P, where any constant memory required will come here, and S of P will have a variable part which will vary, right? So this will give you S of P. Now Now let's understand, right? For example, I just write uh, a basic thing int a, and I write a as 4, and I just write printf a, right? Let's say this is a small program, I'm writing it. Okay, so now you understand that here you don't have any independent variable. What you have is just the a thing which gonna take the memory of integer type, and let's say 4 bytes, right? So though you can write that s of p as 4 plus 0, right, which is again s of p is 4, which is nothing but a constant value, right? You don't have any dependency, you don't have anything, so it's a constant, not a linear equation, not a quadratic, and those kind of stuff, right? So for that, whenever you get s of p as constant, we denote o of 1. So o, big O of 1 means a constant value. So whenever you get the constant value of s of p, you can denote it by big O of n. Whenever you get a linear equation, for example, if I have to give an example, uh, 4 plus 5n, 10 plus 7n, like this, then you represent it by big O of n. To understand the notation, you can again roll back to some of the previous videos where we have discussed the notations. But I am recapping it because it may need it in our future videos, right? So if it's a quadratic equation, in that case, how you are going to define? So for example, you have 7 plus 10n plus n 7 square, or just you have n square, or you just have 8n square plus 5, or you just have 7n square. In this kind of situation, if you get s of p in this format, then you are going to define big O of n square as a space complexity. I think this basic is clear to you, right? So I'll just let me reiterate. I should not go beyond the agenda of the video. It is to let you know that what is the formula of space complexity. All right. One more point I want to focus here is in our future videos, whenever we are calculating the space complexity using this formula, constant plus s of p, my habit to treat constant as 1, not by the size of data type size. All right, so I don't calculate, for example, if you're writing int a comma b, right, in that case I don't treat as 4 bytes 4 byte. I just say this will take one constant space, this will take one constant place. So I treat that as a constant place, one unit constant place, one unit constant place. All right, so this is one more, and then I will discuss about the auxiliary space when we will take some example, right, how we treat that. Correct. So if you have some confusion that why I'm not taking 4 bytes, or I'm not writing 4 anywhere, or some of the actual memory, that's why I'm taking that. I just take it one unit, because why to unnecessary have some calculations, right? For example, you have float, you have integer, right? So these are constant anyways, right? So you can just write one unit constant, one unit constant. So you can write s of p as 2, right? Which is again nothing but big O of n, because we understand that whenever s of p is constant, it is big O of 1, that we have discussed already here. In our next video, let's take some example and continue with the space complexity followed by the time complexity. Thank you.